As you may know, I'm Johnny Walker Dredd. I've been publishing videos on YouTube for nearly 4 years. Most of my videos have been devoted towards getting the truth out there about Kyle Rittenhouse and the Kenosha shootings, as well as the myth of police brutality. I also pick on Rashad Ritchie quite regularly. But I've been thinking about doing a series of videos on the physics of firearms for a long time, but never got around to it. I haven't found much on YouTube devoted to the physics of guns. Most were layman's interpretations of what they thought was occurring. Naturally, for the videos to attract an audience, I need to explain the laws of physics as clearly and accurately as possible, so that even someone like Rashad Ritchie can understand. Hello out there. I am trying to get through.
With cold, blunt analysis cradled in the warmth of reasoning, it's time for Johnny Walker Dredd to straighten you out on a thing or two. Emanating all the way from exciting Las Vegas, Oklahoma, it's time for the Johnny Walker Dredd Show.
For my first video, I figured I would start with the easiest effect to analyze using physics. I chose recoil because 1, everyone knows about it, and 2, the physics of recoil is easy to understand. Most of the explanations of recoil I found are based on Newton's third law. You know, for every force there is an equal and opposite force. However, I'm going to use the conservation of momentum for 2 reasons. Number 1, when expressed in terms of forces, Newton's third law is not fundamental. For example, the claim for every force there is an equal and opposite force is violated in electromagnetism. Conservation of momentum, however, is derived from the most fundamental understanding of spatial symmetry, not experiment. This derivation is called Noether's theorem. Number 2, we want to know the numerical value of recoil, but Newton's third law requires that we also use Newton's second law, which is more difficult and perhaps even impossible. Conservation of momentum, however, is a snap. I'm going to apply a scientific approach that I call the spherical chicken based on an old joke. The spherical chicken requires that you simplify the system as much as possible, examine it, understand it, and only then add complexity to it. This is not the approach used in most leftist fields such as education, which is why they haven't accomplished much. The simplest system we can conjure is the recoilless rifle, where a bullet is fired and the gases generated by the burning gunpowder are expelled toward the rear, like a bazooka. We will assume initially that this rifle is truly recoilless. That is, the rifle doesn't move after firing. To make things really simple, we will set the rifle on an ice rink and pull the trigger electronically, so that the actual force of pulling the trigger doesn't complicate our analysis. Remember, the spherical chicken. The ice rink will reduce the friction to the point where we can comfortably assume it's zero. Again, the spherical chicken. To make the chicken even more spherical, let's all do this in a giant vacuum chamber so that we don't have to worry about the air surrounding the rifle. So what is momentum? Classically speaking, the momentum of an object is equal to its mass times its velocity. P is equal to mv. Pretty simple, right? Why P? Well, it's from a Latin word. Let's just leave it at that. So the equation for momentum is pretty simple. The mass of the objects in our system will need to be expressed in terms of kilograms. In effect, we will be converting the weight of the objects into the mass of the objects. Mass and weight are not the same, but let's not spend too much time on the distinction. Fortunately, we have online unit converters available that make this a snap. The velocity is just how fast an object is traveling and in which direction. So if you are traveling at 45 miles per hour in the northerly direction, your speed is 45 miles per hour, but your velocity is 45 miles per hour north. You'll see why the direction is important soon. The principle of conservation of momentum states that if there is no net external force acting on a system, where forces refer to something pushing or pulling on the system, then the total momentum of the system will remain the same value before and after the trigger is pulled. Here, the system is the combined rifle and cartridge. If we assume no friction, then there will be no net external force acting on the system, and so the momentum of the system, rifle and cartridge, will remain the same before and after we pull the trigger. Before the trigger is pulled, the total momentum of the system is zero. Why? Momentum is mass times velocity, and the system, rifle and cartridge, are not yet moving. Now we fire the rifle. The bullet leaves the barrel at high speed. Let's suppose the bullet travels to the right, which we will call the positive direction. I'm going to use a spreadsheet to perform the calculations. As I explain the calculations, I will pass over each cell slowly so that you can copy the equations inside each cell and do your own calculations. Because momentum is conserved, the total momentum of everything in the system must combine to zero. Remember, I said that the direction of the velocity was important. Suppose this rifle is chambered like an AR-15, firing a .556 bullet that weighs 55 grains, about 0.0036 kilograms of mass, at a speed of 3240 feet per second, about 988 meters per second. Therefore, the momentum of the bullet is roughly a positive 3.5 Walker dreads. Why is the unit of momentum the Walker dread? Because scientists never bothered to give momentum its own unit, so I kind of moved in on that. Perhaps you see a problem here. Because if the total momentum of the system is zero before pulling the trigger, and the bullet has positive 3.5 Walker dreads of momentum after pulling the trigger, then how is momentum conserved? Momentum is supposed to stay the same value, but our system somehow gained 3.5 Walker dreads of momentum. And hopefully you see the answer. The gases that are expelled out the rear have momentum, and this momentum has to be, guess what, negative 3.5 Walker dreads. The negative comes from the fact that the gases are expelled in the opposite direction of the bullet, that is, the negative direction. If we assume, say, 40% of the gunpowder is converted to gas, which is reasonable, and that there are 20 grains of gunpowder in the cartridge, which is common, then 8 grains of gunpowder, that is 0.00052 kilogram, will be converted to gas. Remember, P is equal to mv, so this gas will need to be expelled out the rear at almost 6,800 meters per second. That's why you don't want to stand behind a recoilless rifle when fired. But remember, we fired this gun in a room with no air. Any air outside the gun will drop the speed of the gas quickly because this gas will have to push against it. We can express our calculations in equation form. We can solve for the velocity of the gas rather simply. Now, let's complicate the system a bit more. Instead of being recoilless, the gun is just a typical bolt-action rifle where the gases are now expelled out the front. Once again, we start with the rifle and cartridge at rest, that is, with a total momentum of zero. We're using the same cartridge as before, so we will have the same amount of gunpowder converted to gas. We will assume that the gas travels down the barrel at the same speed as the bullet. Then we have a total momentum of gas and bullet equal to around 4 Walker dreads to the right after pulling the trigger. But how does the total momentum of the system equal zero? Well, we forgot the rifle. In this case, the rifle must recoil to conserve momentum. An AR-15 has a mass of around 3 kilograms. Now our equation states we can solve for the velocity of the rifle, and we get. So, if we set the rifle on the ice and fire it, the rifle will scoot across the ice at about 1.34 meters per second, about like this. This is the recoil. So how can we reduce recoil? The answer to that question is in my next video. Also, what is the physics of the kick that we feel when we fire a gun? And how does this kick compare to other rifles, like the AR-15, given that the AR-15 returns some of the expelling gas to load the next round? That is coming up as well. Let me know if a series of videos on the physics of firearms interests you, and I'll continue punching out more of these videos. However, I do need you to help publicize these videos. I'm really tired of pouring in hours to produce a video and only having 30 viewers. So share them on Twitter, Facebook, YouTube. Let's get the word out. Like my video and subscribe to my channel.